Okay, awesome. Welcome and thank you for joining us today for day 3 of World Space Week and the Georgia Space Grant Consortium and our partners celebrating women in space and just space in general. So I'm super excited today to introduce to you our partner with all of our projects that we have going on in celebrating World Space Week and International Day of the Girl next week, Christina Korp from Space for a Better World and Purpose Entertainment. She is an astronaut wrangler, and we're super excited to have her partnering with us on all of these amazing events. Christina, let me turn it over to you so you can introduce our featured guests today.
I will. Thank you very much, Laurie. We're so excited for World Space Week and having these amazing friends, all these spacey friends of ours coming together to talk about all the cool things with space. So I'm so grateful that 3 of my friends decided to join us today and answer some questions from a bunch of kids, mostly in the Atlanta school area, but also elsewhere. So today I want to start by introducing the 3 panelists. I'm going to, because he's fully on the screen, I'm going to start with my friend Bobak Ferdowsi, who is with NASA JPL. Then we're going to have James Green, who is the chief scientist at NASA, and Dr. Tanya Harrison, who is the most Mars-centric person that I know, almost, except for Buzz Aldrin. So I would like each of you to introduce yourselves and just tell us a little bit about who you are, how you got into space, and what it is that you do now. And so why don't we start with Tanya, because I want to go with ladies first.
Oh, thank you. I feel honored to be almost as Mars obsessed as Buzz. That's great to hear. Yeah, I'm Tanya Harrison. I'm currently the Director of Science Strategy for an Earth observing company called Planet, but my whole career before this was working in Mars missions. So I worked in science and mission ops for a few different NASA missions, including the Mars Reconnaissance Orbiter, which is a satellite that got to Mars in 2006, and it's still operating there today. And then the Opportunity, Curiosity, and Perseverance rovers. And on all of those missions, I worked on camera systems. So my job was either, depending on the mission, to plan what the cameras would take pictures of, and then analyze those images when they came back from the standpoint of a geologist, because I have a PhD in geology. So what is this picture telling us about the history of Mars? And analyzing it from a little bit of an engineering standpoint. Is there anything that this picture is telling us that might say that the camera isn't working properly? Luckily, I don't think I ever ran into that, other than, unfortunately, the time that we lost the Opportunity rover, because I was working on the cameras the days that all we saw were dust before we didn't get any signals back at all. So that was a pretty impactful thing to be working on at the time. My work on Mars specializes mostly in the cryosphere, which is anything that has to do with ice and frozen things, and landslides. So how does stuff fall downhill on Earth, and how can we use that to understand how things fall downhill on Mars? Because there's a lot of cool ways that things can fall down a hill. I got interested in Mars actually because of NASA. I had loved space ever since I was a kid because I grew up watching stuff like Star Trek. I was obsessed with the book, The Magic School Bus Lost in the Solar System. I made my dad read it to me like every single night. If he skipped any of the speech bubbles in it, I got really annoyed, and he was so mad because it would take like 3 times longer to read the book that way. But when the Pathfinder mission landed on Mars in 1997, I was 11, and NASA released these animated GIFs of pictures that Pathfinder took of this little tiny Sojourner rover, the first rover that we ever sent to Mars, driving out onto the surface of the planet. And I saw that and I thought, oh my gosh, I want to work on Mars rovers. And then a couple years later, in 1999, NASA actually had this sort of a competition or a challenge for students to design a base for humans on Mars in the year 2030. And I got super obsessed with it. I learned about it from a PSA, a public service announcement that aired during Star Trek Voyager one night. And I just threw myself into it entirely. And I knew that I really wanted to work on Mars missions. And my first job straight out of getting my master's degree was working in mission ops on Mars orbiters and rovers. So it was like 10 years later. So I'm amazed that I actually got to do what I wanted to do. And I never got tired of it. Every single day, I would, like when I would walk to work, I would literally dance my way into the office because I was so excited to just get to actually work with stuff that was either on Mars or orbiting Mars. And that's literally the coolest thing you could be doing in the solar system. I don't know, maybe somebody else that's working on non-Mars missions would argue that other places in the solar system are cooler, and that's okay too. So it's been a really exciting ride so far.
Well, I love it because my life became obsessed with Mars for quite a while because of working with Buzz. So I know more about Mars than I ever thought that I was ever going to know. And about the moon, at least for Apollo 11. So that's been pretty exciting. Next, we're going to go to my friend Bobak Ferdowsi, who I've known for many years, and we're totally, totally kindred spirits with our hair, which I love. People ask me, how is it that you can have such crazy hair? And I'm like, I work in space. I dip my hair in the cosmos, and Bobak does the same. So, Bobak, I'm so excited that you're here. And by the way, I loved your tweet today about doing a finger trigger to Venus.
Yeah, only slightly embarrassing to me.
I love
Yes,
it. I love it.
was walking along the street last night and saw Venus and was like, looking real good tonight, Venus. And I just feel like I have a weird conversation with the planets occasionally when I see them in the night sky. But it's cool that they're there. It's just wild that we like look up and there's stuff out there.
So when you were a kid, were you like into this already, or tell us how your journey?
Yeah, I mean, I got started probably hooked because of Star Trek a little bit. In all honesty, like I loved sci-fi growing up. I loved I think it appealed to me on two fronts. Like one, of course, just like the wondrous worlds that they built, but two, I think growing up, like as an Iranian American here and in the 80s, even maybe more tumultuous relationship than now. I felt always of like this two worlds, and so this vision of a kind of a utopian future where like going to space was what allows us to reflect on what it means to be human. I really love that sort of philosophy, and I really think that kind of embracing that is sort of what led to my path. And well, how do I make a career out of, I don't know, doing my small part to make sci-fi real. And I think one of the cool things about this this opportunity right now working at NASA is I do feel like in some small way like we're making those kind of futures a little bit more accessible to folks. And so, but like Tanya, I was also inspired very much specifically to kind of go into what I'm doing right now by the Pathfinder mission. I was 17 at the time, and that mission also one of those very first big real internet moments, right, where like you could go online and see pictures from another world, and that changed my relationship, I think, with space from this thing I read about in what felt like kind of a history sense to a thing that was immediate and present and we were doing actively. And so, yeah, then, pursued the degree in aerospace engineering, lucked out incredibly, right, coming to first job here at JPL, and then immediately getting to work on the Curiosity rover on the engineering side of the house. And then now I've had the chance to take that knowledge and apply it to other missions like Europa Clipper and now NICER that I'm working on, which is the Earth Science mission, kind of looking back at our own planet and understanding some of the ongoing changes. So it's been a cool journey, but like, yeah, I still, just that connection, it's still every day I get excited about this chance to work on, I don't know, making a better future.
Well, and I love that President Obama coined you the Mohawk guy when Curiosity landed, which made a lot of people who weren't paying attention to space pay attention to space. Like, wow, a guy who works at NASA working something like this has a mohawk. And that's something that sometimes people in the space world don't understand how cool that is for people like me who, was a musician and singer and stuff, to see that someone who was like me is doing something in science and doing like really cool planetary things. So, that was the first time I ever heard about you. And then I'm very happy to say that we've become friends since then. And I'm so happy that you're here. So then the actual first time I ever met you, I also got to meet in person. I got to meet James Green. So James, who is the chief scientist at NASA. And the cool thing about this was I was more than 8 months pregnant. It was a week before I had my son. I looked like a big blueberry it was at Comic-Con. It was the first ever NASA panel. And it was so cool. The place was jam-packed. And it was clear that all of these people who also love comics and sci-fi and movies and all of that love space too. So Jim, tell us about your journey and we're so excited to hear about all the things that you know, and I have a bunch of questions coming up. So tell us about you, and then we'll go on to the kids' questions.
Well, thanks so much, Christina. I've had a very long career at NASA. My current position is that I'm an advisor to the administrator. So at my location at NASA headquarters, which is Washington, D.C., is we think about the future. We think about what's the next thing we're going to do in space and how are we going to do it. And then we have a number of NASA centers that really have the technology and capability to build the spacecraft and launch them and get them on orbit and land them where we want them to go. Now, early in my career, I did some of that. I got inspired actually by a high school chemistry teacher who ended up being the director of an observatory. So I had a 12-inch Alvin Clark refractor at my beck and call. So at night, I was looking at Saturn or Venus or Mars. I did astrophotography. I did all kinds of stuff with that telescope. And then I went to the University of Iowa and started interacting with other scientists like James Van Allen, the first scientist that launched an experiment and discovered something in space. And we now call them the Van Allen radiation belts. But I've worked on more than 24 missions. I've really enjoyed working with NASA. Indeed, I have a little spring in my step still, and I enjoy going to work and learning all the fantastic things that we're doing. So let me turn it back over to you and not waste any more time.
Yeah, no, what I'm really excited about is that we're working really closely with the Atlanta Public Schools for this big installation, for this project called Aim Higher. And the Aim Higher message and theme came out of I met these sisters from Turkey who had listened to the moon landing on a little Grundig radio. They lived in a village with no running water, no electricity. Their mother couldn't read or write, and their father had a 5th grade education. And the idea that humans made it to the moon made them think, wow, we could aim higher for our dreams. And that's what's really inspired me, because when I heard their story, and by the way, the older sister went on to get her PhD in quantum physics, and the younger sister got her MBA and has a very successful company. To me, that idea of doing this thing that people thought was impossible before, everybody has an impossible dream or something they're not sure they can do. And so the whole theme of all of this is to aim higher. What I love about space and why all of you are here is that I feel like the space community, we all share this sense of wonder. We all share this sense of exploration and trying something new and trying to learn something new. And so that's something I want to inspire young people, especially people who maybe didn't think that it was possible for them, which is why I'm really motivated to inspire women and girls who sometimes think that there's not room for them, or people of color who say, oh, they're not going to hire me. I really want kids to start out with, I can do anything I want. So I like having kids' questions, because all the years that I moderated panels with Buzz Aldrin, and if we had a Q&A at the end, I would always take the kids' questions first. So we're going to start with some questions. And you guys can take turns answering, or whoever feels this is appropriate. And this one in particular is about Pluto. So it might be, this might be James to do this one. And these first couple of questions are from kids at Coretta Scott King Elementary in Atlanta, Georgia. So the first question is, why was Pluto demoted from planet to dwarf planet? And what is the difference?
Okay. So here's a picture of Pluto as we know it. It's a beautiful little globe that we flew by and made some spectacular observations. And in fact, Pluto even has an atmosphere. Now, it's actually fairly small. It's smaller than the United States. But in reality, because it is round and it really exhibits many characteristics as a planet, many planetary scientists still would like to see it named as a planet. But here's one of the major reasons why many other astronomers decided, well, Pluto is a member of a large group of bodies called the Kuiper Belt bodies. These are left over from the early formation of the solar system, and some of them have formed in a very large spherical manner like Pluto. In fact, what really started the discussion is a Pluto-like object was seen very much further away than Pluto, and it was called Eris. And so they thought Eris was actually bigger than Pluto, and therefore the debate now came in, well, should we call Eris a planet or not? And the decision was, no, these are both small objects. They're member of a debris field of material, and even though they're spherical and planet-like, we'll give them a special designation. We'll call them dwarf planets. But it's very controversial still. Many planetary scientists would like to see Pluto be retained as a planet. And that includes me, by the way.
The next question I'm actually going to direct to Bobak, and he may be able to answer this. This is from Jack Mendez, who's the sweetest little boy that I have actually met in person. First, and this is a funny question, and then I'll go to the part that's actually about planet. Do you prefer pomade or gel for your mohawk, and what kind?
Oh man, great question. I use like a paste, like I don't know what you would describe, like a texture paste. I won't shout out any brands because I feel like that's weird. But yeah, it's like it sort of feels like a rough cream with sandpaper in it. I don't know why, but it looks. I like the way it looks. It's like more of a matte, not a shiny.
Jack is like 7 or 8 years old now, and he just got the mohawk, so I think you're his idol.
Excellent. For that. All right, texture paste, Jack.
He's gonna love it. Okay, so Jack says, if the moon blew up, what would happen to the oceans? Would the tides engulf the Earth? Would a ring form around the Earth?
Well, I think I can take a hack at that. It turns out if we lost the moon for whatever reasons, the tides that we do see, we won't see anymore. But that doesn't mean the ocean will rise. It just means it will settle down such that it has much more of a surface rather than the wavy structure. Now, it turns out the sun pulls on the Earth too. And so there'll be a little bit of tide that will occur, although not the kind of tides that we're used to that can be a foot or 2 foot on a regular basis, but maybe 6 or 7 inches or so every day. And that's because the Earth spins and the sun will pull on the Earth, producing that small tide. But the Earth won't get engulfed by water.
Yeah, I will also say, great book on the subject, Seven Eves, covers this and goes into like and it gets a lot of the physics pretty good on how slowly the moon exploding would kind of subtly move the Earth and shift, not move physically the Earth, but move the direction of that we're kind of trending on the Earth, and how that would impact us. So it's a good read, and you can read a lot more about kind of the physics of that situation.
Okay, I'm going to take a question from Demir, who's in 5th grade at Tuskegee Air Academy. He says, do I need to start making good grades now to work for NASA? Anybody want to answer that?
No. I mean, you should keep trying to make good grades, but I mean, let me say it. I was a good student, but definitely by no means a great student. And the nice thing that I've learned about myself is a lot of that just comes down to how much I was interested in subjects. So I didn't not to, I super appreciate the education program that I got, but I found that it was much easier for me to get good grades as time progressed because I kept getting into classes that were more and more like really like when I got to physics, I was like, whoa, can't get give me more of this. And so the great thing is career-wise, the trend is always to getting more and more classes that should be interesting to you. So hopefully it'll happen naturally. But yeah, I will. I don't want to say don't work hard, but also don't stress out about not having the best grades when you're young.
Anybody else?
I had the same experience.
Yeah, go ahead, Tanya.
I had the same experience. It was, I was a good student, through elementary school, junior high. College, I didn't do that well, except in the classes that I was super interested in. Like I was really great in astronomy, anything that I could tie to space, but like just straight up calculus, I did terribly in all of my calculus classes. So I love to tell students, like, you don't necessarily have to be a math genius to work for NASA or to work on, rovers and things like that. It's probably more helpful if you're an engineer than in my case as a geologist. The most complicated math that I ever did was really trigonometry to calculate if a landslide was going to happen. But it's not something that will keep you from getting a job. Like if you are really good at the things that you want to do and you can demonstrate that you are passionate, you're a hard worker, you are great at learning the things that you want to work on, that can get you really, really far. So don't panic too much, but like Bobak said, also, try. Don't just fail all of your classes.
James, do you want to pipe in on that?
Yeah, I will. In high school, I was good in math, science, but also history. So I really enjoyed all those classes. Finding your passion is critical. That is what will drive you towards the goal of where you would work when you're older. And you want to be able to have a job where indeed you love to go to work. And I will agree with Tanya. Not all math is created equal. Okay. Now we do say you need to be good in math, but there's so many different types of math. I did not like geometry. Okay. But I was good in calculus and differential equations. But indeed, find your passion and stick with it. Don't fall behind though. You need to still keep up with your other studies.
Great. So, and I will say, I always say to people, because they'll say to me, oh, astronauts and people at NASA are the elite humans. And I'm like, nah, they're just as flawed as the rest of us. And my point is that, everybody, they're all human, right? We're all human. But if you really, really want to do something, you can figure out a way to do it. And you don't necessarily have to be the genius, in order to do it. And I think that young people understanding that might make them have more courage to go out, for the things that they really want to do. So I'm always trying to say, like, look, I took the bare minimum math and I get to work in space and I never even expected this. This wasn't the plan for my life. So you still have time too, if you want to, if you're really passionate about it. I want to do the next question for Tanya because it's a Mars-based question. So this is from an 11th grader named, I'm hoping I'm saying this name right, Sneh Patel from the Tuskegee Air Academy. I know there are massive dust storms on Mars. One of these storms killed off NASA's Opportunity rover in around 2018. So have we developed a way to predict them so that the future exploration on Mars can be safer for us and rovers? This might be for both you, Tanya, and Bobak.
This is actually a really good question because one of the cameras that I used to work on for many years was a weather monitoring camera for Mars called Marcy. And we took images of the entire globe every day to monitor things like dust storms over the course of the whole Mars Reconnaissance Orbiter mission, so 2006 through now. And this tacked on to stuff we had from Mars Global Surveyor, which was a mission that went from 1997 to 2006. So a lot of people don't realize we actually have a picture of the entire globe of Mars from almost every single day from about, I think, March of 1997 through now, specifically to look at this stuff. And the dust storms are predictable on Mars in that they occur in the same places at the same times of year every year. So we know when dust storm season is in different places. And we know if one of those big global storms, like the one that took out Oppie, is going to happen, we know what time of year it tends to occur. The trick we haven't got yet is we can't tell when you're going to get a global storm necessarily in advance. So we can prepare, we can do things like make sure that if we do see a dust storm brewing, we try to do things like not use a lot of power on the rovers so they can conserve their energy to make sure that they can ride out the storm if it's coming their way. But we don't have a great way to know, like, okay, yes, this year we're going to get a big storm. It's a little bit like trying to predict hurricanes on the Earth. We know when hurricane season happens, but we can't necessarily say, oh, there's going to be a Category 5 hurricane next month, and the following month we're going to get 3 Category 4 hurricanes. We just know when to keep an eye out for them.
Bobak, do you have anything to add or?
Oh, yeah. I mean, with the rovers themselves, obviously, I mean, the great thing is the last two have been, nuclear powered, which helps alleviate some of the risk of having dust storms. But we still have missions like InSight right there now, and potential future missions that might use solar. The amazing thing that, Spirit and Opportunity also really demonstrated that really, felt new to me at least was the fact that there were, these local kind of dust devils and dust clearing events. In fact, right to the point where even InSight is using its own scoop to try to clean off its own solar arrays by adding more dirt, kind of, or whatever, a regolith to the solar arrays to clean them off. So there's clever ways of cleaning your solar arrays. I know people always ask why you don't just bring windshield wipers on Mars, and of course it's a very complex reason of like, if I really thought that I needed to clean these things, it's mass that I'm taking away from instruments and science and other reasons, and it's complex, adds complexity to the system. So plenty of reasons why we don't just build in systems to clean ourselves off too. But the cool thing is, again, current two rovers are more robust, I guess, given their nuclear power. Although it is still hard to do a lot of operations when it's so dusty out, because the visibility is so low. Turns out it's still very dark on Mars, even if you're not susceptible to the last pictures of Opportunity are mind-blowingly dark when you really think about how much dust there was in the atmosphere.
Oh, interesting. I was just thinking about The Martian and how bright it looked in that movie. Okay, clearly that not everything is completely accurate. All right, Jim, I want to ask you, this is a question from Case Lewis in 5th grade from Tuskegee Air Academy. He says, if the outer planets were closer to the sun, would the sun's gravity make them smaller? And where could we walk on them like the inner planets? Does that make sense?
Ooh, yes, that's a very interesting question. And the reason why it's so interesting is indeed we believe those outer planets formed closer to the sun. And then through interactions, gravitational interactions, Jupiter threw out Saturn, Uranus, and Neptune to the current positions that they're in. But they are all gas giants. You can't walk on them. You can walk on their moons, though. They all have big moons, relatively big moons. In fact, Jupiter has the Galilean moons. And one of them, the largest moon, which is Ganymede, is bigger than the planet Mercury, and it indeed has an icy solid surface. But if all the planets were in different orbits, they still would have the same gravity. What would happen is the sun would be pulling on them, creating a different, like we talked about for tides, a different pull that might warp a little bit of their global atmospheres, but it wouldn't be much. And so they pretty well stay the same shape unless they get real close to the sun. Some planets we see that are nearly Jupiter-sized that are close to the sun because they've been thrown inward, that those suns will burn off the atmosphere, and that's just too close. And then the sun has the bigger effect of how it reshapes the planet and therefore the planet's gravity because it loses mass.
Well, thank you. Okay, I'm going to ask a question from, I don't have the name of the child, from Coretta Scott King Elementary School. Are there a lot of women of color who are planetary scientists? I don't know of many, but maybe you guys do that you can tell us about.
Well, there are several. And they're at various locations. Janelle Wellens is at JPL, and I don't know, Bobak, if you've met Janelle. She worked on Cassini, yeah, and there's several others. There's a number of at Goddard Space Flight Center, but there's also women of color that are of Asian descent, non-white women like Mimi Ong, who had major responsibilities in building Ingenuity, which is flying on Mars, or Darlene Lim at Ames, which it really gets involved in a lot of the geological aspects. So yes, there are many, but we always can hire the best people, no matter what their background is.
And someone, this is a different school, from Hollis Innovation Academy in Atlanta. How is NASA encouraging more women and people of color in their programs?
Well, indeed, NASA does recruit for many different types of jobs that it does at a variety of universities. Many universities of which specialize in certain areas, like historically black universities, like Howard University here in the Washington, D.C. area. Goddard Space Flight Center is here and always talking to professors at Howard University looking for the top students. And so that continues to go on all the time. If you want to really get a good idea as to the kind of things that we do in NASA and the women that are involved, NASA has a series of podcasts. I could promote, for instance, my podcast called Gravity Assist, where I talk to some of the most outstanding scientists and engineers, and many of them are women, and many of them are women of color.
I'm going to go to another question from Hollis Academy. We'll start with Tanya on this one. What do you love most about being a planetary scientist?
Oh gosh. I think it's the fact that you never stop learning, so you never get bored with what you do. Like most of the excitement of coming to my job working in operations for missions was I knew I was going to get to look at pictures that in some cases no human had ever seen before, and some of them like pictures of places that we might have never seen on Mars before, or we'd never seen them at that resolution before. And that's a really amazing feeling. And every day was exciting. It didn't matter if it was a picture of a crater or some flat plains or a volcano. They were all equally exciting just to sit there and consume them all. And so I think that constantly getting the opportunity to learn is something really amazing, because you don't always have that opportunity in like every career path that's out there. And it's certainly the thing that has kept me going, for all the years I've been working in this.
Do you guys want to pipe in on that? What do you love most about? Well, I guess, Bobak, you're an engineer, but are you working, right?
I also very similarly love that this job never stops being a learning experience, and it's kind of super. I think one of the things I also love about that is that I get to see myself rise to those challenges, which like coming in here and working with all these incredible people was. And it's daunting, but also like you question whether you can be be one of those people one day. And the great thing about this kind of progression of events and experiences is you do stuff you don't even necessarily realize that you've learned all these things, and then you're asked, in my case, to build a new spacecraft, right? And it turns out you're like, I'm just pulling all this experience out that I just didn't even know that I had gotten this whole time. So like it's the learning the whole way, but also the very fulfilling part of, being able to kind of, how about, this confidence, right? That you're like, I can actually do these things and I am able to rise to these challenges. And I think that's there's not a lot of jobs in which you constantly get new challenges and you get to see kind of how well you're able to kind of move forward on those. So I think it's super fun. It's just new problems, right? There are, again, kind of like similar to Tanya, there's some problems, of course, people have already figured out, but every one of these missions is got its own complexities and issues, and you are forced to sort of, right, to do things that potentially no one has had to do before and to solve a challenge that no one else has had to solve before. And so it makes the job super exciting, also tiring, but like super exciting every day.
Jim?
All right. Well, indeed, like Tanya, I enjoy the science that we're doing. So one of the roles that I have is that I look over the entire set of things that NASA's doing and see some of the new discoveries. NASA's making discoveries each and every day scientifically. So in addition to my own scientific work, where I, do a variety of things with spacecraft data, discover things that, as Tanya said, no one on Earth yet knows or sees. That is really exciting. But I also have a wonderful opportunity to learn what's happening in so many of the other fields. And that's tremendously stimulating and exciting.
So I'm always looking up to the stars, and people ask me all the time, would you go to space if you could? And I'm like, I was made for space. Yes, I would go to space in a heartbeat. And I have been very lucky to have been the fly on the wall of the lives of the Apollo astronauts. I still work with Apollo 16 moonwalker Charlie Duke, and I work with Nicole Stott. I'm going to start working with Cyan Proctor, which is really exciting, who just came back from Inspiration 4, and Susan Kilrain. And the interesting thing to me is that every astronaut I've ever met who's gone to space has discovered the Earth. And so that's one of the things that I think has been pretty profound, is they work their whole lives to get to space, and then they see our planet and realize, wow, we live on a planet. And that's what Nicole Stott says all the time, is like, wow, we live on a planet. We're not separate from space. We're in space, which is so cool. And I think that that's something that, a lot of people who are outside the space world, oh, space is so wasteful. What does space have to do with me? This has nothing to do with my life. And one of the things that I am really passionate about raising awareness in the mainstream world is how much what you guys do benefits life on Earth, benefits what we know in order to hopefully take better care of our planet and start reversing some of the damage. So I'd love for each of you maybe to even talk about some of the work you're doing that is helping life on Earth right now, or that's looking to the future of life on Earth from space research and development. Any of you can start.
Okay, sure. I have mine's super easy answer, right? I get very fortunate to work on a mission called NISAR now, which is a big partnership between us and the Indian Space Research Organization. And that's one of our first really massive kind of collaborations together. And that mission will directly observe the Earth using 2 radar systems. It's a super cool engineering challenge in itself of deploying these massive radar systems in space, but then the science of it, right? The data that we'll gather from these radar will help us better understand kind of the evolving surface of our planet. That data can be used in real time effectively, or near real time, for all sorts of things like crop growth. It can also be used in case of in disaster scenarios, right? Of understanding what the impacts of an earthquake have been in various locations. So there's a lot of very immediately tangible kind of aspects of doing the earth science part of this for the last few years. And then, of course, when this thing launches, the results we'll get from it. I also think even the Mars stuff, though, at the end of the day, for me, right, so much of that is connecting to that same, that sense of what it means to be a human on Earth. Is all about that context of going to another world, and of course recognizing the similarities, but also the differences, right? And looking back and being able, that opportunity to kind of use Mars as a mirror to reflect on ourselves. That's such an important part of, I think, the human perspective and putting ourselves into context. So I think there's I don't see these as 2 different things of like, here's Earth and here's Mars, but sort of as a continuum of evaluating our own existence.
Yeah, how about Tanya? I'll go to you next, because you work at Planet now, correct?
Yeah, so my whole job now is working on Earth stuff. So I took what I learned working on cameras orbiting Mars, and now I can apply them to cameras orbiting Earth because they're really the same. And so the stuff that I work on is working mostly with scientists through groups like NASA, the U.S. Geological Survey, the National Oceanic and Atmospheric Administration, people at universities around the world that are trying to use this satellite imagery of the Earth to understand things like the impacts of climate change. And so we can figure out how to actually create indicators to understand what's going on there. How do we actually track carbon emissions? How do we track where places are experiencing coastal erosion from things like sea level rise, or changes in patterns of flooding because of changes in natural disaster patterns? Where are we seeing more landslides in places where we're having glaciers that are melting that weren't melting before? So there's a very direct impact there on Earth. But like similar to Bobak, a lot of the stuff that we do for Mars, I do see it as this analog for things that we do on Earth. And one of the key things for studying Mars really is to help us put life in the context of the solar system. So to me, the really interesting question is, we know that Mars and Earth were very, very similar at the same point in history as each other when life arose on Earth. So we're trying to answer the question with missions like the Perseverance rover, was there ever life on ancient Mars? And maybe with future missions, is there any life that's hiding in little pockets on Mars today? And if the answer is that there used to be life on Mars and it's gone because Mars is no longer super nice to life as we know it, that's kind of an expected answer. To me, the more interesting answer to the question would be if we find out that there was never any life on Mars, which tells us that something really special happened on Earth that didn't happen on Mars, even though we had a lot of the same environmental conditions. And so by studying the idea of life on Mars, it's helping us put life on Earth in some kind of context. How special are we? Or are we just lucky that Earth has remained habitable for longer than Mars did, and life on Mars only hung around while it was still habitable? So I'm really excited to see the answer to that question for sure.
Cool. Jen?
Okay, so it turns out that comparative planetology has really helped us enormously. So what's going on in Venus, we call a runaway greenhouse effect. This because it's very hot enough to melt iron on the surface. And so that's just too hot. So how did it get that way? And so the Venus modelers in the 70s and early 80s really cracked that problem, and they really showed that greenhouse gases like CO2 were the major culprit in creating such a hot environment. Those planetary scientists brought their code to Earth. And although here at Earth, we were trying to predict the weather, what will it be like tomorrow? Will it rain, et cetera, et cetera? They were playing with the future. What would Earth be like if we continue to emit greenhouse gases over many decades? And so the concept of climate change and global warming in particular really came from planetary scientists that were applying their knowledge from one planet to another. In addition to that, when all of a sudden we were making measurements of a critical area on Earth we call the ozone, this is a layer that is up at 20 or 30 miles that really protect the Earth from very harsh light from the sun that we call ultraviolet light. All of a sudden, holes were appearing, and that ultraviolet light from the sun was penetrating. And so that had never happened before. What was the culprit? Well, once again, planetary scientists who were writing papers about the destruction of ozone on Venus because of chlorine really gave the scientists here the clues that the destruction of our own ozone was from chlorine-derived products like chlorofluorocarbons, which are CFCs, and that was what we needed to start reducing. And indeed they did. We got an international agreement to do that. So comparative planetology is really important. So what happens on Venus can happen on Earth. What happens on Mars could happen on Earth. Mars doesn't have a magnetic field. It lost it. And so the solar wind interacting with the atmosphere of Mars, that will also occur here on Earth when the Earth loses its magnetic field. So this is why we need to study our planets and bring that information back to Earth.
So we're running out of time, and because we started a little late, I'm going to ask a couple more questions because people put them in the chat of the Q&A. So, and I don't know the names of this person, the first person. It says, when do you think people will be able to put foot on Mars? And also, what do you think Mars used to be like Earth is today?
Okay.
Anybody have an opinion about when we'll step foot on Mars? I do.
Yeah. It can't be soon enough for me and Buzz. But we're working hard on that. We're first going to learn to live and work on a planetary surface by going to the moon. So in a matter of just a handful of years, we'll see humans walking on the south pole of the moon and using the resources that are there. That will be tremendously exciting. what we learn from that, we want to carry on to the next step, which would indeed be humans on Mars. So I would say the kids that are listening to this, you're going to see in your generation both humans walking on the moon, but also humans walking on Mars. And that's our plan.
We don't quite know when yet, though. So let's get back to the moon first, right?
Okay, but I would say we got a good chance at the late 30s, early 40s to do that.
I think that's probably more realistic, right? Because we don't have a lot of time. Let me take the next one. Michelle Vellani says, NASA is going to shoot at an asteroid to test planetary defense. How effective is shooting an asteroid to prevent it from crashing into Earth? And how will they secure the small pieces that might make their way to Earth? Anybody know the answer to that? I didn't know we were going to shoot an asteroid.
Yeah, I can tell you all about it. When I was head of Planetary, it was one of my missions that I made happen. It's called DART. And it's
DART.
called, yes, the Double Asteroid Redirect Test. DART is where we have an asteroid, a very large asteroid, and the moon, a smaller asteroid going around this one. And we're going to hit that small asteroid, and we're going to watch it move. It's going to change its orbit. Now, the reason why that's important is that smaller asteroid is still about the size of 2 football fields. I mean, it is really enormous. And if we can move it, then that means we can defend the Earth from asteroids of that size. Now, there are many asteroids of that size, perhaps maybe as many as 20,000 in that size range that cross our orbit, that do indeed have an opportunity to hit our planet. And although looking forward in the next 100 or more years, we don't see any of those events happening, it's just a matter of time. And so we have to learn to defend this planet against that kind of threat. And this is our first mission to do that. It's going to be launched in the November, December timeframe this year coming up, and it'll be an exciting event. And then it will hit this moon of the asteroid Didymos in September of next year.
Oh, great. So we got some near-term stuff coming up. Well, to wrap it up, I want to just go through each one of you. We'll start with Tanya and just say, what is your advice for students, and this is from Hollis Academy, what is your advice for students who want to become a planetary scientist?
That's a great question. So if you want to work on things like the surface of Mars or the surface of the moon, you really want to study geology. This is something that I didn't learn until really far along in my college career because I thought planets are in space, so I should be an astronomer. And that was really interesting, but not the path I actually should have gone down. So I switched to geology in grad school. If you want to do planetary science in terms of atmospheres, like if you want to study the weather on Mars or storms on Jupiter or things like that, then you probably want to study physics or atmospheric science. And then you can work on that kind of stuff. So there aren't a lot of classes that you can take for those usually at like a junior high or high school level, but certainly taking things like math and any of the science classes that you can get will be really good preparation for those.
My daughter wants to be a geologist, astronaut, singer, so I said she could sing to her rocks in space. So
I mean, that's like Chris Hadfield, right? There you go.
Yeah, that's right. Exactly.
Well, Bobak, I want to ask you, I mean, so you get to work with planetary things, but you're an engineer. So what is your advice, to do something like what you do, which is involving that kind of thing, like with rovers and whatnot?
Yeah. Obviously, I think the earlier advice to find your passions is probably the best advice anybody can give you. But I will say things that have helped me out, besides just like the normal courses in engineering, a lot have been about, these are hugely, people-driven missions, right? Like it's easy to look at a spacecraft and think that's a robot, but it's driven by thousands of people working together to make it happen. And so the working on anything that's sort of team-oriented will really help you with those skills of like working in a large collaborative environment. And I think the amazing thing about, nowadays compared to even when I was growing up, is like the availability of things like, FIRST robotics or programs where you can kind of get hands-on collaborative engineering experiences with friends. That to me is I'm so jealous that people get to have that head start nowadays and kind of learn that stuff, because a lot of that has been learned on the job for me. But I would say those are the two things. Like, yeah, definitely the coursework, but also get those chances to work with other folks, because that's what the day-to-day is going to be like. And the better you can do that, the better you can make these, right? Nobody can understand how a Mars rover works by themselves anymore. It's like they're way too complex. So it's really all about being able to trust other people and work with other people to make it happen.
And helicopters now too.
And helicopter, right? Yeah.
Ingenuity, pretty awesome. And finally, Jim, to wrap it up, what's your advice?
You've got to follow your passion. Going to school is great because you have an opportunity to try so many different subjects and see what you like. And when you find those things that you like, study hard. Be the best that you can be. And then everything else will take care of itself. Find your passion and then enjoy it.
And my final message is aim higher for your dreams. And the theme of our World Space Week, Women in Space, and aiming higher for what it is that you want. Don't settle. Go for it. You just never know what incredible things will happen in your life. I want to thank all of you so much for having this conversation. I loved it. I could go on for another hour with you, but I know we all have busy lives and have to move on. So thank you guys so much again. And I can't wait for the kids to get to see their questions answered when they watch this. Bye, everybody. Happy World Space Week.
Thanks so much, Christina. It was delightful.
Yeah,
Bye.
bye everybody.
See you all.
Thank you guys so much. Georgia really appreciates your time today. Thank you so much.
You're welcome. Take care.